You are about to hear something that identifies an absolute fracture in our ability to comprehend space. For generations, beautiful deep-field photographs from our space telescopes presented the universe as a vibrant, tightly packed tapestry, showing glowing spirals and brilliant elliptical star cities, practically touching boundaries as they cluster together in the dark. This digital reconstruction reveals that this cosmic proximity is an illusion created by the flattening effect of our camera lenses. In reality, the vast chasm separating galaxies is a staggering, mind-numbing expanse of hostile emptiness that completely dwarfs the already terrifying gaps between stars, exposing a level of cosmic isolation that challenges our very place in existence. Our slow journey into this intergalactic void begins by establishing the massive leap in scale from stellar distances to galactic distances. When we analyze our own solar system, we measure things in astronomical units, or the distance between the Earth and the Sun. When we look at the gap between individual stars within our own Milky Way, those numbers break down, forcing us to use light years, which is the distance light travels in a single year, totaling nearly 10 trillion kilometers. However, a major mathematical disruption occurs when you look past the outer border of our home galaxy. The Milky Way is a colossal disk of hundreds of billions of stars stretching over 100,000 light-years across. Yet, to reach our closest major galactic neighbor, the Andromeda Galaxy, you must look across a gulf of over 2.5 million light-years. To truly comprehend the terrifying scope of this empty space, we must build a precise miniature model in our minds, utilizing the exact framework we use to map the stars. Imagine shrinking our entire, gargantuan Milky Way galaxy with its hundreds of billions of solar systems and thousands of light-years of thickness, down to the size of a standard, small ping-pong ball. On this scale, individual stars like our Sun become entirely invisible, far smaller than subatomic particles, dissolved into the plastic shell of the ball. If you wanted to place the second matching ping-pong ball representing the Andromeda Galaxy onto this map, you could not place it on the same table or even within arm's reach. You would have to walk over 1 full meter away through an absolute, barren void just to place the next solitary galaxy in the dark. While a 1 meter gap between 2 ping-pong balls might sound manageable, the true structural horror of this model manifests when you look beyond our local neighborhood. The universe does not end with Andromeda. To place the ball representing the massive Virgo cluster, which is the nearest giant collection of thousands of galaxies, you would have to travel over 24 meters away on this exact same scale. To map the entire observable universe using this miniature framework, you would need to construct a sprawling sphere of ping-pong balls stretching over 40 kilometers in diameter. Within this colossal 40-kilometer boundary, the actual physical matter, the stars, the planets, and the glowing gas clouds would occupy less than 1/1000% of the total volume. The universe is not a collection of galaxies. It is a terrifyingly vast sea of absolute nothingness, where galaxies are just microscopic, lonely drops of ink. The true kinetic despair of this distance manifests when we look at our fastest technological achievements. Right now, our most distant spacecraft, Voyager 1, is fleeing our solar system at a blistering speed of over 60,000 kilometers per hour. If Voyager 1 were somehow granted an immortal power source and pointed directly toward the Andromeda Galaxy, its hypervelocity sprint would be rendered completely meaningless by the expanding void. It would require the spacecraft an agonizing 45 billion years of continuous, uninterrupted travel just to cross the threshold of our nearest neighbor. This is over 3 times longer than the entire current age of the universe. Intergalactic space is a physical prison, locking us into our local corner of space-time forever. This absolute isolation introduces a fascinating, deeply humbling realization. The vast empty spaces between galaxies are actively growing wider every single second. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. Mainstream cosmology dictates that the fabric of space-time is experiencing an accelerated expansion driven by an invisible force known as dark energy. Because the gravity holding our local group together is not strong enough to overcome this expansion on a grand scale, distant galaxies are rushing away from us at ever-increasing speeds. Deeper implications suggest that in the far future, the space between galaxies will become so unimaginably vast that their light will no longer be able to bridge the gap to reach our telescopes. The night sky will slowly fade into an absolute pitch-black void, leaving our future descendants completely blind to the existence of the rest of the universe. We invite a calm appreciation for this magnificent, daunting frontier. The terrifying distance between galaxies did not break our science. It merely exposed the true, fragile majesty of our cosmic oasis. By looking slowly at the millions of empty light years that separate our home galaxy from the wider cosmic web, humanity is catching its first true glimpse of the unyielding architecture that rules reality, proving that our entire Milky Way is a solitary, precious island floating inside a dark and beautifully infinite ocean. The modern map of the night sky reveals an immense network of bright, distant galactic structures. Cosmic expansion pushes these vast islands of starlight much further apart than ancient observers ever realized. Recent deep space surveys confirm that outer space contains mostly silent, empty intervals of cold nothingness. This immense void between isolated star systems challenges the traditional human understanding of physical cosmic scale. Astronomers tracking distant cosmic light sources notice a subtle dimming caused by extreme deep space travel. The incredible scale of these silent voids makes our immediate neighborhood feel wonderfully quiet and still. A quiet examination of cosmic distances brings a profound sense of peace to the human mind. The dark sky above holds mysteries that require patience and calm reflection to fully comprehend. Each point of light represents a massive collection of stars, separated by immense, dark, silent gulfs. To look out into the night is to observe history written in ancient traveling light beams. The vast spaces between these distant islands of creation are growing larger with every passing second. Science gently reminds us that our own place in this grand structure is delightfully small. We find comfort in knowing that the universe expands smoothly, without any sudden, disturbing cosmic movements. The slow rhythm of the expanding cosmos provides a perfect background for quiet and restful contemplation. The light from the nearest external system travels for millions of years to reach us. This steady journey across the dark void continues uninterrupted, while the world below sleeps so soundly. Every photon carries a silent message from a past epoch across the wide cosmic ocean. We are merely witnesses to a grand, slow-motion dance that spans across billions of years. The quiet intervals between the stars are far more expansive than the stars themselves now. The immense gaps in the cosmos remind us of the beauty found in pure emptiness. As we observe the distant light, we feel a gentle connection to the grand design. The universe holds its breath as the great galaxies drift further into the quiet night. This peaceful expansion carries everything forward into a future filled with calm and silent wonder. The distance between galaxies is truly a testament to the grand scale of our reality. To understand the immense scale of the cosmos, we must begin with the familiar movements of our own world. Consider the simple act of taking a slow stroll down a quiet, tree-lined path on a calm evening. A single human step covers a small, predictable amount of space that we can easily comprehend with our senses. If you were to walk continuously without stopping for an entire human lifetime, you would circle our planet several times. This journey seems vast to our daily experience, yet it remains a microscopic speck on the cosmic stage. Our minds naturally seek patterns and familiar measurements to make sense of the overwhelming spaces that lie above us. Let us bring the grand architecture of the universe down to a scale that rests gently in the palm of your hand. Imagine our home galaxy, the Milky Way, reduced to the size of a small, delicate grain of sand resting on a table. On this reduced scale, the nearest neighboring large galaxy, known as Andromeda, would be another grain of sand placed far away. You might expect this second grain to sit just a few inches from the first on our imaginary table. In reality, the true proportion requires us to place that second grain of sand many paces away in another room. The space between these two tiny grains is completely empty, containing nothing but quiet, undisturbed air for several yards. This simple visualization reveals that the universe is not a crowded room, but a vast, sparsely populated landscape. When we look at the night sky, we often perceive the stars as a thick ceiling of bright, crowded points. This perspective is a beautiful optical illusion created by our position deep within our own stellar neighborhood. The true nature of the wider universe is defined far more by its empty space than by its glowing matter. Between the great islands of stars lie vast stretches of nothingness that defy our ordinary language and measurements. Humanity has spent centuries developing tools to peer into these quiet zones, trying to map the great empty places. What we find is a consistent pattern of isolated structures drifting slowly through an ocean of absolute stillness. This human-scale perspective allows us to appreciate the grand isolation of our own cosmic home without feeling overwhelmed. The distances are indeed vast, but they are also peaceful, stable, and completely free from sudden chaotic changes. We can look out into the deep dark with a sense of security, knowing the void is a quiet place. The great gaps between the galaxies act as natural buffers, keeping the cosmic order serene and predictable over time. As you rest and contemplate these distances, you can let go of the small, immediate worries of the day. The same physics that keeps the galaxies drifting safely keeps our world spinning gently in the dark. To anchor your thoughts even deeper into this soothing reality, let us think of a simple, quiet grandfather clock standing in a dusty corner of an old, comfortable room. The pendulum swings back and forth with a steady, rhythmic cadence that has remained unchanged for decades. Each tick represents a moment passing on our small planet, while each toque echoes the silent movement of the stars above. On Earth, we measure our lives by these small, precise increments of time, yet the cosmos operates on a clock that moves with immense deliberation. If one tick of the cosmic clock represented 1,000 human generations, the lifetime of a single star would still seem like a fleeting, beautiful spark in the evening air. This slow unfolding of time is not a cold, empty concept, but rather a warm, protective blanket that shields us from the frantic pace of modern life. The sheer scale of the universe ensures that whatever happens in our busy world, the great background of reality remains perfectly undisturbed and tranquil. Let us step outside into a quiet open meadow under a clear midnight sky to further ground our physical understanding of this cosmic stillness. The grass beneath you is cool and damp, holding the gentle freshness of the nighttime air, while a faint breeze leaves the trees whispering softly in the dark. When you lift your eyes toward the celestial dome, you are not just looking upward, but you are looking outward into an ocean of deep space. The bright stars of the Milky Way appear to be close enough to touch, like a brilliant scattering of diamonds on a velvet cloth. However, we must remember that each star is an immense glowing furnace separated from its nearest companion by a distance that defies our earthly vocabulary. If you were to drive a car at highway speeds toward the nearest star, your journey would last for tens of millions of years through the silent dark. This immense cushion of space ensures that the stars never collide or disrupt one another, maintaining a peaceful arrangement that has lasted since the dawn of creation. To bring this vastness down to a physical metaphor we can grasp, let us imagine the solar system as a quiet, solitary house situated in the middle of a vast, dark continent. The sun is a warm, bright lamp burning in the front window, casting a gentle light across the immediate garden, which represents our planetary neighbors. The outer planets drift like silent sentinels in the deeper shadows of the backyard, moving in perfect circular paths that require centuries to complete. Beyond the edge of this property lies a completely dark, unmapped forest that stretches out for thousands of miles in every direction without a single road or pathway. The next nearest house in this cosmic landscape is so far away that its light cannot be seen even on the clearest night from the highest rooftop. This extreme isolation is the true defining characteristic of our universe, a beautiful design that prioritizes quiet privacy and vast open spaces above all else. As you visualize this solitary house, you can feel a deep sense of safety, knowing that the boundary of our home is protected by an immense ocean of absolute stillness. Historically, humanity has always looked up at these silent intervals with a mixture of quiet reverence and gentle curiosity. Ancient mariners used the predictable positions of the stars to guide their wooden ships across the trackless earthly oceans, finding comfort in the sky when the waters were rough. They did not possess the modern instruments we use today, yet they felt an intuitive connection to the grand stability of the celestial sphere. They recognized that while the seasons on Earth changed and empires rose and fell, the pattern of the stars remained completely constant and reliable. This historical continuity reminds us that we are part of a long line of observers who have found solace in the quiet majesty of the night. The same sky that looks down upon you tonight comforted the weary travelers of antiquity. offering a timeless reminder that our world is part of a much larger, peaceful system. Let us now gently expand our thoughts to consider the nature of light itself as it travels through these vast, human-scale analogies. Light is the fastest messenger in the known universe, traveling at an incredible speed that allows it to circle our planet multiple times in a single heartbeat. When you look at the moon, you see it as it was a little over 1 second ago, a delay so brief that it feels completely instantaneous to our senses. However, as we cast our gaze further out toward the distant planets, the time delay begins to grow in a slow and noticeable way. The light from the golden rings of Saturn takes over an hour to cross the quiet void to reach our eyes, meaning we are always looking backward into the recent past. This gentle delay reminds us that space and time are beautifully woven together, creating a cosmic tapestry where distance is measured by the patient travel of light. When we extend this journey beyond the boundaries of our solar system, the timescales become even more wonderfully expansive and relaxing to contemplate. The starlight that enters your eyes tonight from a nearby stellar neighbor may have left its source when your grandparents were just young children playing in the summer sun. The light has been traveling through the absolute silence of the deep void all this time, moving steadily through the darkness while generations of humans lived their lives. It carries no hurry or urgency within its photons, arriving at our world exactly when it is meant to, after a long and peaceful journey. This realization allows us to view the night sky not as a distant, cold reality, but as a living history museum that preserves the beautiful moments of the past. By connecting with this ancient light, we are gently reminded that our present moment is part of a grand, enduring legacy that spans across the centuries. Let us imagine a quiet beach at night, where the small waves lap gently against the dark sand with a soothing, repetitive motion that clears the mind. Each grain of sand on this endless shore represents a star system drifting within the immense architecture of the wider universe. The entire beach, stretching out into the dark, misty distance, represents our home galaxy containing hundreds of billions of stars arranged in a beautiful spiral. If you were to pick up a single handful of this sand, you would be holding more stars than humanity has ever counted with the naked eye throughout history. Yet between each individual grain of sand in your hand, there is a tiny microscopic cushion of space preventing them from grinding together. In the true cosmic scale, this cushion of space is magnified until it becomes a vast, dark highway where a spaceship could travel for millennia without ever encountering a single atom of matter. This realization brings us to a deeper understanding of the profound quiet that exists within the structure of our own galaxy. We often imagine galaxies as crowded, turbulent places filled with cosmic explosions and chaotic movements, because that is what catches our attention in busy documentaries. In truth, the reality is much closer to a slow, silent ballet performed in an auditorium that is completely dark and empty. The stars move along their galactic orbits with such immense deliberation that their positions appear completely frozen to a human observer over a lifetime. There are no sudden shifts or unexpected cosmic collisions to worry about, as the gravity of the galaxy holds everything in a gentle, stable equilibrium. This enduring stability provides a perfect backdrop for restful sleep, knowing that the universe operates on a schedule of absolute peace and predictability. As we contemplate these distances, we can also appreciate the unique position that humanity occupies within this grand, peaceful architecture. We live on a small, beautiful planet that is perfectly situated within the temperate zone of a stable, reliable star. Our atmosphere acts as a soft, protective shield, filtering out the harsh realities of open space, while allowing the gentle starlight to pass through for our enjoyment. We are small enough to be safe from the grand movements of the cosmos, yet conscious enough to appreciate the profound beauty of its vast design. This dual nature allows us to look out into the deep dark with a sense of wonder rather than fear, recognizing that the emptiness is a friend that protects our isolation. The great distance between our world and the rest of the cosmos is the very thing that allows life to flourish in such a quiet, undisturbed manner. Let us think about the ancient astronomers who built the first simple observatories on remote hillsides, far away from the lights of early human settlements. They spent their long, quiet nights mapping the movements of the planets, using nothing but their eyes and simple stone alignments. They noticed that certain stars moved against the background of the night sky, like wandering campfires traveling through a dark, trackless wilderness. These early observers did not feel frightened by the vastness, but rather felt a deep sense of harmony with the natural cycles of the earth and sky. They understood that the regular movements of the heavens provided a dependable structure for human life, guiding the planting of crops and the telling of time. This ancient wisdom reminds us that the scale of the cosmos is a source of order and stability designed to comfort the human spirit. To deepen this sense of calm, let us consider the absolute perfection of the vacuum that exists between the stars and galaxies. On Earth, we are accustomed to a world filled with constant sound, movement, and atmospheric friction that creates a busy sensory environment. In the deep void of space, there is no air to carry sound waves, meaning that the wider universe exists in a state of absolute, perfect silence. The greatest movements of cosmic history happen without a single whisper or rustle passing through the darkness. This total silence is not an empty absence of life, but a positive presence of peace that expands outward in all directions forever. When you quiet your mind and listen to the stillness of your room, you are tuning into the same fundamental silence that defines the vast reaches of the universe. Let us imagine a tiny dust mote floating lazily in a single sunbeam that cuts through the darkness of a quiet, shuttered room. This small speck of dust represents our entire planet Earth, carrying all of our history, our cities, our mountains, and our oceans through the cosmic dark. The sunbeam represents the warm energy of our star, providing just enough light and comfort to keep our world alive and vibrant. The rest of the dark room represents the vast, unexplored regions of space that surround our immediate neighborhood, extending outward for unimaginable distances. This image allows us to see our home from a perspective of gentle humility, recognizing that we are small but completely secure within the grand layout of the house. The vastness of the room does not threaten the tiny dust mote, but simply provides a large, peaceful space for it to float gracefully. As we let our minds drift further into this human-scale perspective, we can appreciate how the laws of physics operate identically across these vast distances. The same gravity that causes a small, ripe apple to fall gently from a tree in an autumn orchard guides the majestic movements of distant galaxies. The same light that reflects off a quiet lake at sunset travels across the cosmic void to reveal the ancient secrets of the universe to our telescopes. This universality of nature means that the cosmos is not a strange alien place, but an extension of the very world we touch and feel every day. We can understand the universe because it is built from the same simple, beautiful components that make up our own homes and bodies. This fundamental connection brings a deep sense of familiarity and comfort, allowing us to feel at home anywhere in the wide cosmic landscape. Historically, human cultures have often envisioned the universe as a series of concentric crystal spheres spinning softly around our world. They imagined that each sphere carried a planet or a collection of stars, creating a beautiful celestial music as they brushed against one another. While our modern scientific understanding has replaced the crystal spheres with open space, the sense of harmony and beauty remains completely unchanged. We now know that the spheres are made of gravity and time, holding the stars in their positions with a delicate, invisible touch. The celestial music is the silent rhythm of physics guiding the cosmic expansion with an elegance that surpasses any human composition. This historical evolution of thought shows that no matter how much our knowledge grows, the universe always reveals itself to be a place of profound beauty and order. Let us consider the immense patience that is built into the fabric of the world we are exploring tonight. A galaxy does not rush to form its structure, but takes billions of years to slowly arrange its stars into a perfect, balanced pattern. The light from a distant cluster does not hurry across the void, but travels with a steady, unyielding pace that honors the grand scale of the distance. This complete lack of urgency is a wonderful lesson for our busy minds, reminding us that the most important things in reality take time to unfold. We can release the need for immediate answers and fast results, allowing ourselves to exist in the quiet, present moment. The universe is patient, and we can be patient too, as we listen to the slow, steady heartbeat of the cosmos. To further ground this perspective, let us imagine a vast, smooth sheet of dark glass stretching out into the darkness in every direction. This glass represents the fabric of space itself, perfectly stable, completely rigid, and entirely transparent to the passage of light. Occasionally, a tiny drop of pure starlight falls upon this surface, creating gentle ripples that expand outward in slow, wide circles. These ripples travel for millions of years across the glass without ever losing their shape or blending into chaotic noise. This visualization helps us understand that space is not an unpredictable, turbulent storm, but a smooth, dependable medium that preserves the order of things. The distant galaxies rest upon this fabric like beautiful glowing ornaments drifting securely through the quiet night. As you prepare to move your thoughts toward the wider scales of the universe, take a moment to appreciate the absolute stability of your current position. The ground beneath you is firm and steady, supported by the deep rock of a planet that has spun reliably for billions of years. The air you breathe is cool and constant, provided by a natural system that works perfectly without any conscious effort on your part. The stars above are in their proper places, keeping their ancient vigil over our world with a fidelity that has never failed. This immediate sense of security is your anchor, allowing your mind to wander safely into the great empty places of the cosmos. You are protected by the laws of nature, surrounded by a vast cushion of space and held in the gentle embrace of deep time. The universe is wide, the night is quiet, and you are completely safe within the grand design. To extend our view, we must leave the comforting boundaries of our solar system and move out into the local galactic neighborhood. The space between individual stars within the Milky Way is the first great distance we encounter on our journey. Even here, the emptiness is profound as light itself takes multiple years to travel between the closest stellar neighbors. Astronomers use the speed of light as a standard cosmic yardstick to measure these quiet interstellar intervals. We understand that stars are born, live their long lives, and fade away within these local boundaries. Yet there remains a mild mystery regarding how the subtle gravity of distant stars influences the outer edges of our system. We accept this uncertainty calmly, knowing that the balance of forces is incredibly stable and enduring over billions of years. This realization brings a deep sense of security as we prepare to move our perspective even further outward. Moving beyond the edge of our home galaxy, we enter the vast domain of the local group of galaxies. This cosmic neighborhood consists of a few dozen systems bound together by a shared and gentle gravitational embrace. The distances here are measured not in light years, but in millions of light years across the deep void. We understand that these galaxies are slowly moving relative to one another in a calm and predictable cosmic choreography. A mild, unresolved mystery involves the exact distribution of invisible dark matter that helps guide this slow galactic dance. Scientists observe the effects of this hidden material, but its precise nature remains quietly elusive to our current instruments. We accept this lack of complete knowledge as a natural part of our ongoing exploration of the cosmos. This cosmic modesty allows us to transition smoothly outward into the even greater structures that lie beyond our local cluster. Our perspective now expands to encompass the grand scale of cosmic superclusters, which are immense networks of galactic groups. These structures represent some of the largest organized patterns found anywhere in the observable universe. The space between these superclusters is so vast that it constitutes the primary volume of the entire cosmos. We understand that these great walls of galaxies are separated by immense regions known to science as cosmic voids. A mild mystery persists concerning how these giant empty bubbles formed so perfectly in the early history of time. The grand scale of these voids reminds us that emptiness is the natural state of the wider universe. We contemplate these massive, quiet spaces with a sense of peaceful wonder as our minds drift with the cosmic current. To fully appreciate the magnificent layout of this cosmic architecture, let us imagine ourselves floating in a state of absolute suspension, far above the standard celestial pathways. From this elevated vantage point, the grand arrangement of matter resembles a delicate, glowing spider web spun across a dark, silent attic. The bright threads of this web are composed of thousands of individual galaxies stretching out in long, elegant filaments that intersect at dense cosmic junctions. Between these filaments lie the great voids, which look like massive, translucent bubbles of pure, undisturbed space. These spherical dark intervals are so vast that a beam of light would need hundreds of millions of years just to cross from one side to the other. There is no turbulence or chaotic motion within these bubbles, only an enduring state of absolute stillness that blankets the grand structure. As you visualize this cosmic tapestry, you can feel your thoughts becoming as light and expansive as the filaments themselves, drifting effortlessly through the quiet layout. Let us consider the profound implications of these cosmic voids, which occupy the vast majority of our observable reality. On Earth, we are accustomed to thinking of space as a crowded environment filled with stars, planets, and swirling clouds of colorful dust. The reality of the deeper universe is completely different, revealing that matter is actually a rare and precious exception to the rule of emptiness. The grand superclusters are merely thin, delicate borders that define the edges of these immense regions of absolute nothingness. Astronomers studying these empty zones find that they contain almost no atomic material, holding perhaps only a single lonely atom in a volume equivalent to a modern human house. This realization brings us to a mild and beautiful mystery concerning the historical origin of these giant cosmic bubbles. When scientists look back at the earliest light in existence, they see a universe that was completely smooth, uniform, and evenly distributed. Over billions of years, the subtle influence of gravity began to pull matter together into the delicate threads we observe today, leaving the great voids completely empty. However, the exact mechanisms that allowed these massive bubbles to clear out so perfectly remains a topic of quiet, ongoing research among modern cosmologists. Now let's slowly expand outward. One level beyond our own solar system lies the Milky Way, our home galaxy. To a human, the Milky Way is unimaginably large. It contains hundreds of billions of stars, each perhaps holding its own family of planets. If our solar system were the size of a single grain of sand, the Milky Way would be the size of a large city. It takes light, the fastest thing in the universe, about 100,000 years just to cross from one side of our galaxy to the other. Scientists understand the Milky Way by observing the way its stars orbit a common center, a quiet, swirling dance of gravity that has been repeating for over 13 billion years. What we know so far suggests that we are a typical spiral galaxy, a beautiful, orderly structure of gas and dust. But even with everything we've learned, there are still things we don't fully understand about our own home. We see hints of dark matter holding the edges together, acting like an invisible scaffolding we cannot touch. Not because we're missing something urgent, but because the universe moves slowly and we have only been watching for a heartbeat of cosmic time. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. With that in mind, let's move outward once more to an even larger scale. Ga, Ga, Ga. To truly understand the titan that is IC 1101, we must first linger for a moment in the foyer of our own home, the Milky Way. When we look up at a dark sky, we see a misty river of light flowing across the heavens. To the ancient Greeks, it was spilled milk. To others, a celestial path. Scientifically, we know it as a barred, spiral galaxy, a swirling disk of dust, gas, and at least 200 billion stars. Our sun is just one of those stars, tucked away in a quiet suburb known as the Orion Arm. We are roughly 26,000 light years from the bright, crowded center, spinning at a comfortable pace that takes 230 million years to complete a single orbit. The last time we were in this exact spot in space, dinosaurs were only just beginning to walk the Earth. This is the rhythm of the local neighborhood. It is a slow, majestic carousel. We think of our galaxy as massive, and in human terms, it is. If you were to try and count every star in the Milky Way, 1 star per second, you would be counting for nearly 7,000 years. It is a number that exceeds the span of recorded human history. And yet, when we compare this to the largest galaxy ever found, the Milky Way begins to feel like a small, cozy village. Our home spans about 100,000 light years. It is a vast distance, one that light, the swiftest messenger, takes a millennium of centuries to cross. But the universe is a ladder of scales, and we are currently standing on one of the bottom rungs. Scientists understand the Milky Way by observing the motion of the stars near its heart. There, stars move with a frantic, hidden energy. orbiting a central point of immense gravity. This is Sagittarius A*, a supermassive black hole. It is the anchor of our galaxy, a dark sun around which all else revolves. Yet, despite its power, it represents only a tiny fraction of the galaxy's total mass. The rest of the mass is a mystery. When we measure how fast the stars at the outer edges are moving, they seem to be moving too fast. By all the laws of visible matter, they should be flying off into the void, like water droplets spun from a wet cloth. But they stay. They are held by an invisible hand. This is the invisible scaffolding mentioned before dark matter. We cannot see it, we cannot taste it, and it passes through your body right now without leaving a trace. It is a ghost that holds the stars in place. It makes up the vast majority of our neighborhood's weight, yet it remains silent. Scientists estimate that for every gram of normal matter, the stuff that makes up trees, oceans, and your own heartbeat, there are 5 grams of this mysterious substance. We are like children looking at a magnificent building and only seeing the windows, unaware of the steel beams behind the glass. But there is no tension in this mystery. The Milky Way has been held together by this invisible support for over 13 billion years. It is not going anywhere. It is a stable, maturing structure. We see other galaxies in our local group, like the Andromeda Galaxy, which is currently drifting toward us at 250,000 miles per hour. Even at that speed, the collision won't happen for another 4 billion years. The universe is so empty that when our 2 galaxies eventually merge, the stars themselves will likely never touch. They will simply pass by each other like ghosts in a hallway, eventually settling into a new, larger arrangement. The Milky Way is a place of constant, quiet recycling. In the cold clouds of gas and dust between the stars, gravity is always at work. It pulls the dust together until it grows hot and dense, eventually igniting into a new star. When those stars die, they exhale their elements back into the void: carbon, oxygen, iron, the very ingredients that eventually formed the Earth and everything on it. We are literally made of the recycled breaths of ancient stars in this local neighborhood. It is a closed system of cosmic elegance. However, as we look further out, we realize that the Milky Way is part of a small, relatively lonely cluster called the local group. We have a few dozen neighbors, most of them small dwarf galaxies that look like tattered clouds. We are the big fish in a small pond. But if we were to travel toward the constellation of Virgo, or further still toward Serpens, the density of the universe begins to change. The ponds become lakes, and the lakes become oceans. When we look at the Milky Way from the outside, it is a beautiful, thin disk with graceful arms. It is a fresh galaxy, still forming stars, still vibrant with the blue light of youth in its spiral limbs. It is a place of birth and movement. But the giants we are searching for, the IC 1101s of the deep, have long since moved past this phase. They have stopped the frantic business of star birth. They have become something more singular, more monolithic. Imagine the Milky Way as a single sheet of paper. To represent the scale of the largest galaxy found, you would need to stack thousands of sheets of paper until they reached the height of a tall building. The sheer volume of space occupied by our neighbor is a drop in the bucket compared to the volumes we are about to explore. Our local neighborhood is a sanctuary of sorts, a quiet, predictable corner of the cosmos, where the light of 200 billion suns provides a sense of familiar warmth. But the horizon, is calling. Beyond the edges of our dark matter halo, beyond the reach of the Andromeda Galaxy's gravity, lies the Great Attractor and the vast clusters of the Laniakea supercluster. We are moving away from the spiral life, the life of arms and disks, and toward the elliptical life, the life of pure, concentrated mass. In this transition, we leave behind the blue stars and the gas clouds. We move toward a region where the stars are older, redder, and packed together in densities that would make our night sky look like a solid wall of gold. We are moving toward the center of the Abell 2029 cluster. If the Milky Way is a suburban home, the environment around IC 1101 is a sprawling, ancient metropolis that never sleeps, yet never moves. The uncertainty of our own galaxy, the mystery of its dark matter, the exact shape of its hidden arms, serves as a gentle reminder that we are still learning the alphabet of the universe. We are like travelers who have only just stepped out of their front door and are already amazed by the size of the street. But the street leads to a city, and the city leads to a continent. As you settle deeper into your rest, let the Milky Way fade into the background. It is a sturdy home, and it will be here when you wake. Its 230 million year orbit will continue, unbothered and serene. The dark matter will continue to act as its silent guardian, but your mind is now free to drift further. We are crossing the intergalactic void, the vast, empty space where light travels for millions of years without hitting a single atom. It is quiet here, between the galaxies. There is nothing to see, nothing to hear, only the soft expansion of space itself. We are moving toward a light that has been traveling for 1 billion years. It is a pale yellow glow, growing larger and larger until it fills the entire field of vision. This is the light of 1 trillion souls, the light of a galaxy that has forgotten how to be small. With that in mind, let's move outward once more to an even larger scale. As we drift further from the familiar spiral arms of our Milky Way, we enter the great intergalactic desert. This is a place where distance takes on a physical weight. Between our home and the destination we seek, there are stretches of nothing so vast that entire civilizations could rise, reach the stars, and fade into dust without ever crossing the gap. In this space, the atoms are so few that you could travel for 1,000 years and never encounter a single grain of matter. It is a vacuum of such purity that it makes the air in your room feel like a dense, heavy liquid. Here, in the profound stillness of the local neighborhood's edge, we begin to realize that the universe is not made of objects, but of the space that holds them. To understand the journey we are taking, we must look back at our own cluster, the local group. It is a small, intimate collection of galaxies. The Milky Way and Andromeda are the two anchors, spinning around each other in a slow, multi-billion-year embrace. Around us are the stragglers, the Magellanic Clouds, the Triangulum Galaxy, and dozens of dwarf galaxies that look like tattered scraps of silk. This is our porch. It is a cozy corner of the cosmos. But as we move outward, the neighborhood begins to change. The gaps between the stars are replaced by the gaps between the galaxies. We are leaving the era of the individual sun and entering the era of the collective glow. Imagine the time it takes for a message to travel across this neighborhood. If you were to send a beam of light from one side of the local group to the other, it would take nearly 10 million years to arrive. Any news we receive from our neighbors is ancient by the time it reaches our eyes. We are looking at a history book written in the language of photons. And There is a deep intellectual comfort in this delay. It means that nothing in the universe happens suddenly. Everything has a long lead time. The light of the giant galaxy IC 1101, which we are now approaching, has been traveling toward us since before the first mountains on Earth were raised toward the sky. It is a light that has seen the birth of every creature that ever walked the ground beneath you. As we move further out, the individual stars of the Milky Way merge into a single, faint smudge of light behind us. Our sun is no longer visible. Our planets are gone. The entire history of humanity is contained within a speck of light that is slowly vanishing into the distance. This challenges how we think about our own importance, but it does not diminish us. Instead, it expands us. We are the consciousness that has traveled this far. We are the part of the universe that is looking back at the porch we just left. There is no urgency to return. The local neighborhood is safe. It is held in the same laws of physics that govern the giant we are about to meet. Scientists observe these distant scales by using gravitational lenses, places where the mass of a cluster is so great that it bends the light from even more distant objects, like a cosmic magnifying glass. It is as if the universe is helping us to see it. It is providing the tools for its own discovery. This suggests a sense of cosmic continuity, a feeling that the universe is not just a random collection of things, but a coherent system that wants to be understood. As we move outward, we are not moving into chaos. We are moving into a more complex form of order. The light of IC 1101 is now a dominant presence in our field of vision. It is no longer a smudge. It is a sprawling, golden continent of light. It is an elliptical giant, a structure that has moved past the frantic star-birth phase of our own neighborhood and into a state of graceful endurance. While the Milky Way is still working, busy making new stars and recycling gas, IC 1101 has finished its labor. It is a place of rest. Its trillions of stars are old, steady, and red. They move in paths that are millions of light years long. To a star in this galaxy, 1 billion years is just a season. But even with our best telescopes, there are things about this transition that remain accepted unknowns. We don't fully understand the warm, hot, intergalactic medium, the thin, invisible gas that lingers between the clusters. It is so hot that it should be glowing brightly, yet it is so thin that it is almost impossible to detect. It is a ghost of the early universe, a remnant of the fire that started it all. For now, that uncertainty is simply part of the picture. We don't need to measure every atom to feel the warmth of the cosmic breath. We can simply exist in the space between the explanations. As you drift deeper into the night, imagine yourself floating in that intergalactic void. You are halfway between our local neighborhood and the giant galaxy. Behind you is the familiar glow of home. Ahead of you is the golden orb of the deep. You are in the most peaceful place in existence. There is no gravity here to pull you down, no atmosphere to limit your vision. You are a point of awareness in a sea of infinite space. The expansion of the universe is carrying you gently forward, a silent current that moves without effort. Over immense spans of time, the light of the trillion souls in IC 1101 will wash over you. It is a light that has been purified by its journey through the void. It is a light that has lost all its shadows. In the heart of the largest galaxy, there are no dark corners. Everything is illuminated by the soft, amber radiance of ancient suns. This is the goal of our expansion, to move from the small, shadowed world of the local neighborhood into the broad, unshadowed light of the cosmic giants. With that in mind, let's move outward once more, to an even larger scale. We are leaving the porch and entering the city. We are moving from the familiar stars to the structures that hold the stars. The universe is getting larger and we are getting quieter. There is no rush. The light has been traveling for 1 billion years. It can wait for us to drift into its embrace. The steady, unceasing flow of time and space is the only thing that matters now. The numbers are fading. The distances are merging. There is only the light, the yellow glow of 1 trillion suns, waiting to tell us the rest of the story. When we think about size, we often imagine it in human terms. Distances we can walk in an afternoon, the height of a mountain that takes a day to climb, objects we can see with our own eyes, like a cathedral or a sprawling city. For example, if you were to walk consistently without stopping, it would take you about 9 years to walk the circumference of the Earth. That feels like a long time. It represents a significant portion of a human life. But in the context of the universe, the Earth is not an object of size, it is a point of departure. Astronomers often feel like cartographers trying to map an ocean while standing on a single grain of sand. This comparison isn't perfect, but it gives us a calm place to begin. Beyond our atmosphere, the definition of an object begins to change. It stops being something with a hard edge and starts becoming a collection of influences. Now, let's slowly expand outward. Consider, for a moment, the concept of a long journey in your own life. Perhaps it is a drive across a continent where the landscape shifts slowly from green forests to rolling plains. You measure that progress by the hours on a clock, the meals you eat, and the rising and setting of the sun. To us, 1,000 miles is a formidable distance. It is a distance that requires planning, fuel, and time. Yet, if we were to shrink the entire Earth down to the size of a single glass marble, that 1,000-mile journey would be a microscopic scratch on its surface, invisible to the naked eye. We live our entire lives on the skin of this marble, rarely considering the depth of the void that begins just a few miles above our heads. If you were to stand in an open field and look up at a clear night sky, your eyes are reaching out across distances that the human brain isn't quite equipped to process. When you see the moon, you are looking at an object that is about 239,000 miles away. If you could drive a car to the moon at highway speeds, it would take you about 5 or 6 months of continuous driving to get there. No stops for rest, no traffic, just a straight line through the silence. This is our nearest neighbor, a mere stone's throw in the cosmic sense, yet it already exceeds the scale of a human life's daily movement. As we move further, we must leave behind the measurements of miles and kilometers. They become too small, like trying to measure the width of the Atlantic Ocean using a ladybug as a ruler. Instead, we use the speed of light. Light is the fastest thing we know of, traveling at 186,000 miles per second. In the time it takes you to blink, light has already circled the Earth 7 times. It is a speed so fundamental that it sets the pace for the entire universe. And yet, even at this impossible speed, the universe is so vast that light itself takes time to get anywhere. When you look at the moon, you are seeing it as it was 1.3 seconds ago. You are already looking into the past, if only by a moment. To understand the largest structures in existence, we have to get comfortable with this idea of light time. Think of it as a cosmic delay. The further out we look, the further back in time we see. It is a gentle, natural form of time travel. If the sun were to suddenly go out, we wouldn't know for 8 minutes. For those 8 minutes, we would continue to feel its warmth and see its light, living in a beautiful, lingering echo of something that is already gone. This realization isn't meant to be unsettling. It is meant to show you how the universe buffers us from its true scale. We are tucked away in a quiet corner of time and space, shielded by the sheer slowness of information. Imagine walking through a vast, silent forest at twilight. You can see the trees immediately around you with great detail, the texture of the bark, the shape of the leaves. But as you look further away, the trees become silhouettes, and eventually they blend into a soft, indistinct grey haze. The universe is much like this forest. Near us, we see individual planets and stars. But as we expand our perspective, those individuals begin to group together. They become part of something larger, something more diffuse. We often think of objects as things made of solid matter, a rock, a house, a mountain. But as we move into the human-scale perspective of the cosmos, we see that objects are often mostly empty space. If you were to take an atom, the building block of everything you see, and blow it up to the size of a football stadium, the nucleus would be like a small marble in the center, and the electrons would be like tiny gnats buzzing around the very highest seats in the stands. Everything in between is nothing, emptiness. To you, the chair you are sitting on and the planet beneath you are made almost entirely of this nothingness, held together by invisible forces. This same principle applies to the stars and galaxies. If we imagine our galaxy, the Milky Way, as a vast city, the stars are like individual streetlights. From a distance, the city looks like a solid glow of light, a single object of immense proportions. But as you move inside, you realize the streetlights are blocks, even miles apart. There is a great deal of dark, quiet space between them. When we talk about the largest object, we are talking about a structure that is made of billions of these cities, all arranged in a way that suggests a grand, hidden order. Scientists spend decades trying to find the edges of these structures. They use massive telescopes that act like buckets, slowly collecting the faint, tired photons of light that have been traveling for millions of years just to reach us. What they find is that the universe isn't just a random collection of things thrown into a box. It has a texture, it has a shape. It looks like a web, or perhaps the neurons in a brain, or the foam on top of a cup of coffee. It is a collection of filaments and voids where the objects are so big that they define the very curvature of space itself. As you lie there, let the scale of this begin to wash over you. You are a part of this structure. The atoms in your body were forged in the hearts of stars that lived and died billions of years ago. You are a way for the universe to look back at itself and wonder about its own size. There is no need to feel overwhelmed. Just as a single cell in your body doesn't need to understand the complexity of your entire life to do its job, you don't need to grasp the 93 billion light-years of the observable universe, to be a part of it. You are anchored here, on this 9-year walk-wide marble, safe and still. We are about to step off this marble and begin the climb. We will move through the solar system, past the giants of gas and ice, and out into the interstellar dark. We will see things that defy the imagination, but we will do so with the same calm, rhythmic pace. The universe is patient. It has been expanding for 13.8 billion years, and it is in no hurry to finish. Now, let us take that first step away from the familiar. Let us leave the lights of Earth behind and look toward the sun, our local anchor and the first true giant in our path. To understand the vastness of the largest objects ever discovered, we must first reconcile our own physical presence with the immediate neighborhood of our star. We often think of our world as a massive, solid foundation, a place of continents and oceans that take days to cross by air and weeks by sea. But as we elevate our perspective, the Earth begins to shrink, transitioning from a world of infinite variety into a singular, fragile marble of blue and white, suspended in a velvet dark that is deeper than any night you have ever experienced on the ground. Consider the distance between your home and the Sunday. It is approximately 93 million miles. To a human mind, 93 million of anything is an abstraction, a number that sits on a page without a physical weight. But let us try to feel that distance. If you were to board a commercial jet and fly toward the sun at a constant cruising speed, you would not arrive for 19 years. You would spend nearly 2 decades in the air, crossing a silent, airless gulf just to reach the nearest star. This is the scale of our local backyard. It is a distance that defines the boundaries of our biological reality, yet in the cosmic census, it is a microscopic gap. The sun itself is the first true lesson in the universe's love for the gargantuan. It is a sphere of glowing plasma, so immense that if it were hollow, you could pour 1,300,000 Earths into it. Imagine a large glass jar filled with tiny grains of sand. Each grain is an entire world, with its own history, its own mountains, and its own billions of people, all rattling around in the bottom of a container that represents a single average star. This comparison isn't meant to diminish the Earth, but to provide a calm place to begin our ascent. When we speak of the largest objects in the universe, we are moving towards structures that make our sun look like one of those grains of sand. Scientists understand the sun by observing its heartbeat, the way it pulses with magnetic energy and sheds its outer layers in a constant solar wind. This wind creates a bubble around us, a protective shield called the heliosphere. This is the first object we encounter that lacks a solid surface. It is a structure made of pressure, particles, and light. It reminds us that as we move outward, the definition of an object begins to change. It stops being something you can touch and starts becoming a collection of influences. The sun is not just a ball of fire, it is a gravitational anchor that holds the solar system in a steady, rhythmic dance, ensuring that the planets do not wander off into the lightless void. Astronomers often feel like cartographers trying to map an ocean while standing on a single grain of sand. We look out from our small vantage point and try to measure the height of mountains we can never climb. Beyond our atmosphere, the very concept of up and down dissolves, replaced by a sense of inward toward gravity and outward toward the unknown. As we drift away from the sun, the light begins to thin. The warmth of the hearth fades, replaced by the bracing, silent cold of the interstellar medium. This is the space between the stars, a realm that was once thought to be empty but is actually filled with the ghosts of dead suns and the seeds of new ones. Imagine walking across a frozen lake at night. The ice is thick and the air is still. In the distance, you see the faint glow of a cabin's window. That cabin is the nearest star system, Alpha Centauri. To reach it from our sun, even at the speed of light, would take over 4 years. If you were walking at a human pace, the journey would take tens of thousands of generations. You would be born, live, and pass away in the dark, as would your children and their children, all while the destination remained a distant, unwavering point of light. This is the neighborhood of our galaxy. It is a place of immense, lonely roominess, where the objects are islands separated by oceans of silence. What makes this strange is not just the distance, but the time. Because light takes time to travel, looking into the distance is a form of archaeology. When you look at a star that is 20 light years away, you are seeing it as it was 2 decades ago. You are seeing a ghost of the past, a lingering image that has been traveling through the vacuum just to reach your eyes. This challenges how we think about now. In the universe, there is no universal now. There is only the perspective of the observer, caught in a slow-motion replay of cosmic history. As we move further out, we encounter the true giants, the stars that defy the limits of stellar physics. There are stars like Betelgeuse, a red supergiant that is so large it would swallow the orbits of Mercury, Venus, Earth, and Mars if placed at the center of our system. It is a bloated, dying sun, a majestic structure of gas that is preparing to return its material to the galaxy. These giants exist in a state of quiet equilibrium, balancing the inward crush of gravity against the outward pressure of their own light. They are the elders of the stellar community, reminding us that even the most massive objects have a life cycle, a beginning, and an inevitable conclusion. But even these stars are not the largest objects we have found. They are merely the building blocks. To find the true titans, we must look at how these stars gather together. They form clusters, and those clusters form galaxies, and those galaxies form the great filaments that weave the cosmic web. This hierarchy of scale is a fundamental rule of the universe. Small things make large things, which in turn make impossibly large things. It is a nested reality, like a series of boxes that never ends. There is a mild awe in realizing that the atoms in your own body were once forged inside the hearts of these giants. The carbon in your cells, the iron in your blood, and the oxygen you breathe were all created in the nuclear furnaces of stars that lived and died long before the Earth was even a cloud of dust. You are a part of this scale expansion. You are the universe's way of looking back at itself and saying, I am very large, and I am very old. As you lie there, let the weight of this perspective ground you. You are safely tucked away in a quiet arm of the Milky Way, far from the chaotic centers of galactic collision. You are shielded by the sun's magnetic breath and anchored by the Earth's steady gravity. The vastness of the cosmos is not a threat, it is a context. It is the backdrop against which your life unfolds, providing a sense of scale that makes your daily worries feel as light as a photon. We are preparing to move beyond the individual stars. We are going to look at the structures that hold billions of suns in their grip. We are moving toward the great attractors and the walls of galaxies that span the observable horizon. But for now, just breathe with the Sunday. Feel the slow, heavy pull of the solar system as it moves through the galaxy. There is no rush to understand the whole picture at once. The universe has been here for 13 billion years, and it is perfectly happy to wait for you to catch your breath. The definition of an object has already begun to shift in your mind. It is no longer just a stone or a tree. It is a system. It is a relationship. The largest object we've ever found is not a solid thing you could kick with your foot. It is a pattern of matter and energy so vast that it defines the very shape of space. To see it, we must continue our journey outward, past the familiar stars, into the deep, echoing halls of the superclusters. But for tonight, this human-scale perspective is enough. It is a bridge between the world you know and the universe you are part of. It is a calm, stable platform from which we can observe the infinite. Let the light of the sun, now a distant and gentle memory in the dark, be your guide as we step into the next loop of our expansion. And for now, that uncertainty, the sheer impossibility of the scale, is simply part of the picture. It doesn't need to be resolved. It just needs to be felt. With that in mind, let's move outward once more, to a scale where stars are like grains of dust, and galaxies are the only objects that matter. Dark expanse, untouched and silent, a world frozen before human ancestors ever discovered fire. Its journey inward becomes a pilgrimage, a rare awakening from an existence mostly defined by stillness. You allow that thought to settle in your mind like a snowfall, slow, quiet, inevitable. Turning your attention to the interior, you picture layers of organic molecules preserved within the ice. These molecules carry the signatures of chemistry that predates life on Earth. Some may be precursors to the building blocks of life itself. You reflect on the scientific theory that comets like this one might have delivered essential ingredients to early Earth, seeding the young oceans with materials that helped life begin. The comet becomes not just a witness to the past, but a participant in it, a traveler that may have played a role in the emergence of life. This possibility expands your sense of connection to the comet, as though its long journey is intertwined with your own story. You imagine a fragment of the comet breaking off, drifting through space, eventually falling toward Earth in some distant age. This fragment enters the atmosphere, heating briefly before landing softly on an ancient plain. Inside that fragment lies a molecule that will someday become part of something living. You feel a gentle wonder at this possibility, knowing that life is a series of connections stretching across time. The comet becomes a reminder that you, too, are part of an ancient chain, shaped by events that occurred long before your birth. As the echoes continue to unfold within you, you realize that the comet is not simply telling a story. It is inviting you to remember something about yourself. It reminds you that time is vast, that change is slow, and that endurance often comes from stillness rather than motion. You let this reflection settle softly, feeling its quiet truth expand within your chest. The ancient world carried by the comet mirrors the ancient world carried within every person, the one made of memories, instincts, and stories passed down through generations. The comet rotates slowly beneath you, revealing a cluster of crystalline ridges glinting in sunlight. These ridges formed early in its history, shaped by interactions with cosmic radiation. You imagine them as frozen sculptures, untouched since the earliest days of the solar system. Their beauty lies not in perfection, but in endurance. the way they stand unchanged despite the passage of millions of years. This endurance becomes a metaphor for the human experience, the way certain memories remain bright even after time reshapes everything else. As the comet moves steadily toward the inner solar system, you feel the echoes begin to shift again, as though preparing to lead you toward a broader view. The past is rich, deep, and endlessly fascinating, but the universe is always nudging you to expand your perspective. You sense the transition forming, a gentle widening that pulls you outward. And yet, even now, the universe seems to whisper that to understand this ancient traveler fully, you must lift your gaze from the past and look toward the vast expanse waiting beyond the horizon, where the cosmic perspective unfolds in quiet, shimmering light. And yet, even as the echoes of ancient memory drift quietly across your awareness, like frost carried on a slow wind, you feel the universe beginning to expand around you again, opening not backward, but outward, widening into something larger than history. The comet continues its patient glide, but now its presence becomes a doorway, a quiet threshold, inviting you to step beyond the intimacy of its frozen past and into the boundless stage upon which it performs its long, deliberate journey. You sense the shift, the way one notices dawn easing across a horizon, subtle at first, then unmistakable, filling everything with new light. The past was deep, but the cosmos is deeper, and your thoughts gently tilt upward, drawn toward the enormity that always surrounds you, even when you forget to look. You imagine yourself drifting farther from the comet now, giving it space so you can see it in context. It hangs like a dark, textured ember against a canvas of stars that stretch in every direction, silent and indifferent, yet somehow comforting in their vastness. The beauty of this view is not in its detail, but in its scale. Everything becomes quieter as you float here, as though distance itself has softened the noise of human thought. The comet no longer appears as a solitary traveler. It becomes part of a great, swirling choreography of planets, light, dust, and invisible forces shaping the motion of entire worlds. You feel the cosmic perspective settling into your chest like a slow, deep breath. As you rotate gently in this stillness, your gaze catches the faint glow of distant galaxies, each one a sprawling archipelago of stars. You imagine what it would be like to drift among them, each cluster containing billions of suns, each sun potentially hosting its own worlds, each world perhaps sheltering life that dreams in its own way. The scale becomes so immense that your mind cannot hold it all, yet it tries, stretching like a quiet tide to accommodate the immensity. The comet becomes a tiny note in a universal symphony, and yet a meaningful one, because even the smallest notes change the shape of the music. You feel yourself softening into this realization, allowing the enormity to calm you rather than overwhelm you. Your thoughts turn to the gravitational forces that guide the comet's immense orbit. You picture the sun not as a blinding disk, but as a soft sphere of light, pulling gently on everything around it, shaping the trajectories of planets, asteroids, dust, and icy wanderers. The sun's gravity extends far beyond sight, reaching into regions so distant that its influence feels more like a memory than a force. And yet it persists, guiding the comet inward after millions of years in the frozen outskirts. You imagine gravity as a quiet hand resting on the comet's shoulder, not pushing or pulling abruptly, but reminding it which direction home lies. You consider how this same gravitational hand shapes your own existence without you ever feeling it directly. The Earth rests in its orbit because of this cosmic choreography, spinning through space with a grace so reliable that most days you forget to marvel at it. The comet becomes a reminder that motion is universal, that everything is in continuous, unbroken movement. You feel a soft humor in the fact that humanity, so proud of its schedules and routines, lives on a planet that spends every moment hurtling through space at unimaginable speed while pretending it is sitting still. Even the quietest night is not truly quiet. It is an endless voyage through a universe that never rests. The stars shimmer more brightly as you look across the sky, revealing constellations whose shapes have been recognized for thousands of years. You imagine ancient astronomers tracing these patterns, assigning stories and gods to the stars, trying to make sense of the enormous canvas overhead. Their interpretations may have differed, but their awe was the same feeling that rises inside you now as you let the cosmic perspective widen your vision. You imagine those early stargazers sitting beside fires, pointing upward, whispering questions in languages lost to time. You feel connected to them, a quiet link forged through wonder. Your gaze shifts to the galactic plane, that luminous band stretching across the darkness. It is composed of billions of stars, dust lanes, and clouds of gas glowing softly in scattered starlight. You imagine drifting closer, weaving through massive nebulae where new stars are born. These stellar nurseries stretch across light years, immense clouds of hydrogen shaped by pressure, temperature, and gravity. The cosmic perspective reminds you that creation is not a single event, but an ongoing process, unfolding in every direction. The comet you follow was formed from similar clouds, gently drawn together into a solid body by forces so patient that they operate across eons. You imagine drifting still farther outward until the solar system shrinks to a tiny point of light. From this vantage, everything familiar becomes small, almost fragile. And yet there is something reassuring in that smallness. It reminds you that the universe is immense enough to absorb every worry, every mistake, every uncertainty. Your perspective widens until even the comet's long journey feels like a brief flicker in a great ocean of time. You sense a gentle humility rising inside you, softened by the knowledge that you are part of something vast, ancient, and ongoing. As you float in this expansive stillness, you think about the human desire to understand the universe. Scientists spend entire lifetimes studying light, gravity, motion, particles, and energy, yet the cosmos remains full of mysteries. You picture a NASA astrophysicist standing in a quiet laboratory late at night, illuminated by the glow of computer screens. They examine new data from a distant observatory, watching the comet brighten as it approaches the sun. The scientist rubs their eyes, sips cold coffee, and smiles, knowing that this small piece of information contributes to a much larger understanding. Their dedication mirrors the comet's patience, both moving steadily toward deeper revelation. The cosmic perspective deepens as you reflect on the nature of time itself. The comet moves slowly, yet its orbit spans millions of years, connecting the past, present, and future in a single arc. Time stretches differently here, becoming less linear, more fluid. You imagine watching the comet's entire orbit from above, a long ellipse drawn like a thread across the solar system. The comet is currently at one tiny point on that thread, but its path stretches far beyond what any human lifespan can encompass. This thought reminds you that your own life is part of a larger continuum, a brief moment in a story that began long before you and will continue long after. You let this understanding sink in, feeling the softness of its truth. The cosmic perspective does not diminish your existence. It enlarges it by placing it within a vast context. Every breath you take becomes part of a cosmic rhythm. Every thought, a reflection of the universe's capacity for complexity. You are made of atoms, forged in ancient stars, shaped by forces that operate across billions of years. The comet becomes a companion in this realization, a reminder that even solitary wanderers are connected to everything around them through the invisible threads of physics and time. You imagine the comet continuing its slow rotation, revealing surfaces shaped by countless encounters with cosmic radiation. Its texture tells stories that span ages, illuminated now by sunlight that has traveled across millions of miles. This sunlight carries the imprint of nuclear reactions deep within the sun's core, reactions that will continue for billions of years to come. You imagine riding a beam of sunlight from the sun to the comet, feeling the gentle warmth slipping across the frozen surface, waking ancient molecules with a soft touch. This simple interaction becomes a metaphor for awareness, the way small insights can awaken memories or stir new understanding. As your thoughts settle into this expansive calm, you begin to sense the gradual return of introspection. The cosmic perspective is vast, but the human mind eventually begins to look inward again, drawing meaning from the grand view. You feel a gentle tug guiding you back toward yourself, back toward reflection, back toward the human experience. And yet, even now, the universe seems to whisper that to understand your own place within this vastness, you must descend from the cosmic view into the quieter terrain of human meaning waiting in the next unfolding moment. We find ourselves looking at a world that challenges every notion of habitability we once held. Nature often presents us with environments that seem far too hostile for any known biological life. The silence of the void is punctuated only by the steady pulse of a dying stellar wind. Some researchers suggest that the surface temperatures fluctuate wildly between the day and night side regions. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. We continue our journey through the data to understand the true nature of this strange place. The universe remains indifferent to our desire for finding a twin of our own blue home. Every measurement brings us closer to the quiet reality of our place within the vast cosmos. We move forward now into the deeper details of the light we have recently captured. The light from Proxima Centauri takes roughly 4 years to reach your eyes. It is a journey through a quiet, cold vacuum, crossing trillions of kilometers before it touches the sensors of our most advanced instruments. You are looking at a neighbor, yet it is a neighbor shrouded in a permanent, dim twilight. The star itself, a red dwarf, is smaller and cooler than our sun, glowing with a deep ruby hue that colors everything in its reach. As we settle into this observation, notice the stillness of the data. The James Webb Space Telescope does not see colors the way you do. It sees heat. It feels the faint warmth of a planet that never turns its back to its sun. One side of Proxima b is forever bathed in that dim red glow, while the other is trapped in a perpetual, frozen night. There is no wind to carry the warmth, only the steady, silent radiation of a star that has lived for billions of years. We are watching a world in equilibrium, a balance of fire and ice that has existed long before we looked up. The sensors are calm, the transmission is steady. We are simply witnesses to a distant reality. This planet, Proxima Centauri b, resides in what we often call the habitable zone, a term that suggests comfort but here implies a different kind of intensity. To be in the habitable zone of a red dwarf is to be very close, tucked in toward the warmth like a traveler huddled over a dying ember. The orbit is short. A year on this world lasts only 11 Earth days. Imagine the speed at which it must travel to maintain its position, a silent, rapid circling in the dark, held tight by the gravity of a star that is much older and much slower burning than our own. We watch this motion through the fluctuations in the infrared spectrum, seeing the slight dip in light as the planet passes across the face of its sun. There is a profound patience required in this science, a willingness to sit in the dark and wait for the photons to arrive, one by one, carrying the signature of a world we may never touch. The James Webb Telescope provides us with a new way of feeling this distance. Instead of blurry pixels, we now have data points that describe the energy balance of the surface. We look at the thermal phase curve, a long and gentle wave that tells us how the planet heats up and cools down as it moves. The curve is sharp. It tells us that the heat does not travel well. On Earth, our thick atmosphere acts like a conveyor belt, moving the warmth of the tropics toward the poles and evening out the sharp edges of the day. But on Proxima b, the heat seems to stay exactly where it is dropped. The day side is a fixed bullseye of thermal radiation, while the night side remains a deep, unyielding well of shadow. This tells us something fundamental about the air, or the lack thereof. It suggests a world stripped bare, a skeleton of a planet that has endured the temperamental nature of its star for eons. As we continue to watch, we must consider the nature of the star itself. Proxima Centauri is an M-dwarf, a class of star that is notoriously active in its youth. While our Sun is a steady, yellow hearth, Proxima is more like a flickering candle in a drafty room. It produces flares that are hundreds of times more powerful than anything we experience. These flares are not just light, they are torrents of X-rays and ultraviolet radiation that slam into the planet's upper layers. Over millions of years, this constant bombardment acts like a cosmic sandblaster, slowly peeling away the layers of gas that might have once protected the surface. We see the aftermath of this process in the lack of water vapor signatures. We see a world that has been refined by fire, a place where the chemistry of life as we know it would find no purchase in the parched and irradiated soil. Yet, there is a strange beauty in this desolation. When we talk about a world that terrifies, we are often just describing a place that is indifferent to our presence. The landscape of Proxima b is likely a masterwork of geology, shaped by forces we can only simulate in our labs. Without the softening effects of rain or wind, the mountains would be jagged and sharp, their peaks reaching up toward a sun that never moves. The craters from ancient impacts would remain crisp and untouched, a chronological map of the solar system's history written in stone. There is a dignity in this permanence. It is a world that does not change because it has already reached its final form. It is a monument to the endurance of matter in a high-energy environment. We find ourselves drifting deeper into the data, moving from the broad thermal maps to the finer details of the minerals. The telescope looks for the silica feature, a subtle bump in the light that would indicate the presence of rocks similar to those in our own deserts. We find traces of basalt and iron, the heavy elements that settled into the core of the planet when it was still molten and young. The chemistry is familiar, but the context is alien. On Earth, iron is the heart of our magnetic field, a spinning dynamo that protects us from the sun. On Proxima b, We do not know if such a shield exists. If the planet is tidally locked, its rotation might be too slow to generate a protective bubble. It sits exposed, a naked rock in a sea of radiation, enduring the star's gaze without blinking. This leads us to a moment of quiet reflection on the nature of habitability itself. We often search for Earth-like worlds, but perhaps we should be searching for the limits of what a world can be. Proxima b is a baseline, a testament to the extremes of the cosmos. It tells us that a planet can be the right size and the right distance, and still be a place of absolute, crystalline silence. The terror we feel is the terror of the void, the realization that life is a delicate and rare occurrence in a universe that is mostly made of radiation and vacuum. We are looking at our nearest neighbor and finding a mirror that reflects back the sheer luck of our own existence. The contrast between our green world and this red shadow is a lesson in cosmic humility. The data transmission remains steady. The telescope is a silent sentinel, orbiting a point in space, far from the interference of Earth's warmth. It is cold out there, almost as cold as the night side of the planet it observes. This shared coldness creates a resonance between the observer and the observed. We are using a frozen machine to study a frozen world. The precision is staggering. We are measuring temperature changes of just a few degrees from trillions of kilometers away. Each pixel of data is a precious commodity, a tiny spark of information that has traveled through the dark to tell us that we are not alone in the universe, even if our neighbors are made of silent stone and irradiated dust. As we transition into the next phase of our observation, we look toward the horizon of Proxima b. If you were to stand at the edge of the day side, in the permanent sunset of the Terminator line, the sky would be a deep, bruised purple. The stars would be visible even during the day, because there is no thick air to scatter the sunlight into a bright blue canopy. You would see the constellations of our own sky, but they would be shifted, rearranged by the perspective of a 4-light-year journey. Our own sun would be a bright, steady star in the constellation of Cassiopeia, a small yellow dot marking the place where you were born. From there, Earth is just a memory, a tiny flicker of light lost in the glare of a much larger universe. The silence of Proxima b is not an empty silence. It is a heavy silence, filled with the history of a world that has survived the birth and middle age of its star. It is a silence that invites us to slow down, to match the pace of the cosmic clock. There is no need for fast conclusions or sensational headlines. The reality of the planet is enough. It is a world of extreme contrasts, a place of fire and ice, a neighbor that remains forever out of reach. We watch the data stream in, the long, slow lines of the infrared spectrum, and we feel the weight of the distance. The universe is vast, and we are just beginning to learn the language of the stars. The sensors are calm, the transmission is steady. We are simply witnesses to a distant reality. We watch the red dwarf glow, a steady ruby in the dark, and we wait for the next photon to arrive. There is a deep peace in this waiting, a sense of participating in a process that is much larger than ourselves. We are the eyes of the galaxy, looking back at itself, trying to understand the many ways that a planet can exist. Proxima b is one of those ways, a harsh, beautiful, and silent way. It remains there, locked in its orbit, a quiet companion in the dark until the end of time. The scale of this observation forces us to rethink our place in time. A single orbit of Proxima b is a mere heartbeat in the life of the universe. 10 days pass, and the planet has completed a journey that takes our own world a full year. This rapid cycling creates a sense of urgency in the data, a flicker of movement in the otherwise static void. Yet, despite this speed, the planet's face never changes. The same craters are always illuminated. The same plains are always in shadow. It is a paradox of motion and stillness. We are observing a world that is rushing through space at incredible speeds, yet it is trapped in a frozen state of existence, a prisoner of its own sun's gravity. As the James Webb Telescope continues its mission, it will look at other planets, other stars, and other galaxies. But Proxima b will always be special because of its proximity. It is the first step in our journey outward, the first test of our ability to understand the worlds that lie beyond our own solar system. What it found was not a second Earth, but something perhaps more important, a reminder of the diversity of the cosmos. It found a world that challenges our definitions and expands our understanding of what is possible. It found a place of terrifying beauty and profound isolation. And as we continue to watch, we find that the more we learn about Proxima b, the more we learn about the precious, fragile nature of the blue world we call home. The data remains steady. The light continues to fall on the gold mirrors. We are here, and we are watching. To understand the distance to Proxima Centauri b, imagine you are taking a very long walk. If you could walk through the vacuum of space at a steady, rhythmic pace, it would take you over 900 million years to arrive. Every step you take represents a tiny fraction of the void. If Earth were the size of a small glass marble on your table, Proxima Centauri would be another marble placed thousands of kilometers away. The planet itself is slightly larger than our own, a heavy rock hanging in the dark. If you stood on its surface, you would feel a bit heavier, your footsteps more deliberate and grounded. The sun in the sky would look much larger than ours, a bloated, dark orange disk that never sets. It would sit motionless on the horizon, casting shadows that never move, never shorten, and never lengthen. Time, there does not feel like time here. There are no Tuesdays. There are no mornings. There is only the long, unchanging now. It is a world where a shadow cast by a rock today will be in the exact same place 1,000 years from tonight. It is a slow, heavy existence, far removed from the frantic spinning of our own world. On Earth, we are defined by the cycle of the sun. We wake with the light and sleep with the dark. Our bodies are tuned to a 24-hour rhythm that governs our hormones, our moods, and our very sense of progress. But on Proxima Centauri b, that rhythm is broken. Because the planet is tidally locked, there is no rotation relative to its star. If you were to stand on the day side, the sun would hang in the sky like a heavy, unblinking eye. It does not move from east to west. It does not set. It simply exists, casting a long, still shadow that becomes a permanent part of the geography. Welcome to the grand theatre of the cosmos. Across the vast expanse of time and space, there exists a narrative that surpasses all others in scale and complexity. It is the story of everything that has ever been and everything that will ever be. Tonight, we turn our gaze upward to the infinite velvet dark, to explore the fundamental forces and celestial bodies that define our existence. This journey begins not on a distant star, but right here on the blue marble we call home. Humanity has always been a species of explorers, driven by an innate curiosity to understand the lights that dance above us. From the primitive star charts drawn in caves to the sophisticated orbital observatories of the modern era, our quest for knowledge has been relentless. Consider the history of those who first dared to map the heavens. Ancient civilizations looked at the same constellations we see today and wove them into the fabric of their mythologies, creating stories that served as both guidance and philosophy. Yet, the transition from myth to science marked the true dawn of our understanding. Think of the pioneers like Galileo Galilei, who turned a crude spyglass toward the moon and forever shattered the notion that the heavens were perfect and unchanging. His courage to observe and report what he saw, despite the immense social and political pressure of his time, remains a guiding principle for every astronomer today. We stand on the shoulders of these intellectual giants, using the principles of physics they helped define to unravel the mysteries of the universe. The cosmos is a realm governed by strict physical laws, yet it remains profoundly mysterious. When we discuss the nature of our universe, we must speak of gravity, the invisible architect of all things. It is gravity that pulls dust and gas together to form the first stars, and it is gravity that dictates the orbital dances of planets and moons around their host stars. In the heart of many galaxies lie the most extreme manifestations of this force, known as black holes. These objects are regions of space where gravity is so intense that nothing, not even light itself, can escape their grasp. They are not merely destructive voids, but essential components that shape the evolution of the galaxies they inhabit. The study of black holes challenges our understanding of reality, forcing us to reconcile the predictable laws of classical physics with the strange behavior of matter near the event horizon. To observe these phenomena, we have moved beyond the limits of human eyes. We have built monumental facilities designed to peer deeper into the fabric of space and time. Agencies around the globe now coordinate massive engineering feats, constructing telescopes that act as time machines. By capturing light that has traveled for billions of years, these instruments allow us to witness the universe in its infancy. The James Webb Space Telescope is perhaps the most significant achievement in this endeavor. Designed to observe the infrared spectrum, it pierces through the dense clouds of interstellar dust that once hid the birth of stars and planetary systems from our view. Each image captured by this observatory is a dataset that refines our models of galaxy formation and chemical evolution. Consider the complexity of our own solar system. It is a diverse neighborhood of planets, moons, asteroids, and comets, each telling a unique story of formation and change. We have sent robotic emissaries, our rovers, to traverse the desolate and fascinating surface of Mars. These machines are the robotic pioneers of our time, drilling into rock and analyzing soil to search for signs of past life and to understand the geological history of a world that was once far more active than it is today. Every transmission sent back from these rovers is a triumph of engineering and a testament to the persistent human drive to seek out the unknown. They operate in harsh conditions, powered by the sun and steered by researchers who feel the weight of every command sent across the millions of miles of vacuum. The science of cosmology addresses the biggest questions of all. How did the universe begin, and how will it end? Current evidence points to a colossal expansion that began roughly 13.8 billion years ago. Since that moment, the universe has been growing and cooling, allowing for the formation of the complex structures we observe today. We live in an era where we can measure the cosmic microwave background, the afterglow of the Big Bang, which provides a snapshot of the universe when it was only a few 100,000 years old. This, combined with our observations of dark matter and dark energy, suggests that we see only a small fraction of what actually constitutes the cosmos. The vast majority of our universe is made of components we cannot directly perceive, yet we know they exist by the way they influence the movement of galaxies. The collaborative nature of modern astronomy cannot be overstated. It is a global endeavor that transcends borders, languages, and political divides. When we study the life cycle of stars, we are observing the factories that created the very atoms that make up our own bodies. Every carbon atom, every oxygen molecule, and every trace of iron in our blood was forged in the hearts of stars that died long before our solar system was even a glimmer in the cosmic dust. We are, quite literally, made of star stuff. This realization connects us to the history of the universe in a profound way. We are the mechanism by which the universe has become conscious of itself. Think of the technological advancements that have trickled down from our space exploration efforts. The materials science required to protect spacecraft, the complex computer algorithms used to process data from distant reaches of the galaxy, and the breakthroughs in energy efficiency are all results of the challenges faced when we push the boundaries of what is possible. By attempting to understand the environment of space, we have become better stewards of our own environment here on Earth. The perspective gained from seeing our planet as a fragile blue sphere suspended in an immense dark void has influenced our culture, our politics, and our environmental policies. As we look toward the future, the possibilities are limited only by our imagination and our commitment to exploration. We are planning missions to explore the icy moons of Jupiter and Saturn, where hidden oceans might harbor the conditions necessary for life. We are refining our techniques to detect exoplanets, searching for another world that might share the characteristics of our own. The search for extraterrestrial intelligence continues to evolve as we listen for signals from across the interstellar divide. Even if we find that we are alone, the search itself is worth the effort, for it teaches us more about the uniqueness and the value of the life we have already found. The beauty of the universe is not just in its vastness, but in its mathematical elegance. The patterns we see in the spiral arms of a galaxy are reflected in the growth of biological structures on Earth. The laws of motion that govern a planet in its orbit are the same laws that dictate the trajectory of a falling apple. This interconnectedness is the foundation of physics, the language that allows us to translate the silence of the stars into a coherent story. We are not separate from the universe. We are a vibrant, active, and curious part of it. As we continue this exploration, we must always remember the importance of fundamental research. Much of what we know today began as theoretical curiosity, a question asked by a scientist who wondered why things worked the way they did. The transition from theoretical wonder to technological application is the engine of human progress. When we invest in astronomy and space physics, we are investing in the expansion of human knowledge, which is the most valuable commodity we possess. The challenges are undeniably great. The distances are unfathomable. The conditions are hostile, and the timescales are beyond the capacity of human experience to truly comprehend. Yet, we persist. We build better telescopes, we design faster rockets, and we train the next generation of scientists to take up the mantle. There is a sense of wonder in knowing that there is so much left to discover. The universe is not a closed book. It is an open exploration that rewards the curious and the patient. Consider the role of the modern astronomer. They are no longer just people looking through eyepieces. They are data scientists, engineers, and visionaries who work with vast arrays of sensors and computer networks. They navigate the complexities of international cooperation to ensure that the findings of one are shared with all. This spirit of sharing is the heartbeat of science. It is why we can speak of these things today, and why we can look forward with anticipation to the discoveries that will be announced tomorrow. In concluding this reflection on our place in the cosmos, consider the responsibility we hold. We are the current witnesses to the history of the universe. We have the capability to look back in time and the technology to project our reach into the future. Whether we are studying the formation of planets, the cooling of white dwarfs, or the expansion of the dark energy that permeates the void, we are engaging in the most noble of human endeavors. We are seeking to understand the truth of our origins and the nature of our destiny. So, let us keep our eyes on the stars. Let us continue to support the agencies and the individuals who dedicate their lives to exploring the unknown. The next great discovery might be just beyond the next horizon, hidden in the data of a telescope or revealed by the sensors of a probe. The universe is waiting to be understood, and we are ready to listen to its story. Through our combined efforts, through the relentless application of logic and the burning flame of curiosity, we will continue to push back the boundaries of the dark and fill the map of the unknown with the light of knowledge. This is the enduring legacy of the human spirit, a spirit that refuses to be confined to the ground, a spirit that insists on reaching for the heavens to find its true place among the stars. The journey is far from over, and the best parts of the story are yet to be written. Everything that we have discussed, from the smallest particle in a laboratory to the largest structure in the universe, is part of one singular, grand, and beautiful process. It is a process that we are honored to participate in and privileged to understand. May our pursuit of this understanding never cease, for in the light of the stars, we find the reflection of ourselves. The chronicle of our exploration continues, pushing deeper into the tapestry of the night sky, where the rules of the macrocosm unfold in grand displays of energy and matter. When we contemplate the life cycle of stars, we are witnessing a narrative of birth, maturity, and inevitable transformation. From the vast, cold clouds of molecular gas that collapse under their own gravity to the violent, brilliant supernovae that seed the galaxy with heavy elements, the process is one of constant renewal. Each star acts as a cosmic furnace, synthesizing elements in its core through the process of nuclear fusion, balancing the inward pull of gravity against the outward pressure of radiation. When a massive star reaches the end of its lifespan, it undergoes a spectacular collapse, creating the elements essential for life and scattering them across the interstellar medium, which will eventually form the next generation of stars and planetary systems. This cycle is the fundamental mechanism of chemical evolution, turning the simple hydrogen and helium born in the first minutes of the universe into the complex chemistry that allows for life to emerge. Beyond the stars, we turn our attention to the structure of galaxies themselves. Whether they are spiraling disks adorned with glowing dust lanes and clusters of young blue stars, or elliptical collections of ancient red stars, each galaxy is a gravitationally bound city of billions of individual suns. Our own Milky Way is a barred spiral, a massive entity that houses our solar system in one of its quieter suburbs. Understanding how these massive structures grow and interact requires us to look at the large-scale architecture of the universe, where galaxies are organized into clusters and superclusters, connected by filaments of dark matter that form the cosmic web. This web is the scaffolding upon which the visible matter of the universe is hung, and mapping it is one of the primary goals of modern observational cosmology. Consider the role of dedicated space observatories in mapping this web. Telescopes, such as the Hubble Space Telescope, have provided us with iconic views of distant galaxies, allowing us to estimate the age of the universe with remarkable precision. By measuring the recession velocity of these galaxies and their distance from us, astronomers have been able to confirm the expansion of space itself. This expansion is not merely galaxies moving apart through static space, but the stretching of the very fabric of space and time. Furthermore, the discovery that this expansion is accelerating has led to the inclusion of dark energy in our cosmological models. Dark energy, an enigmatic force that seems to act as a repulsive pressure, dominates the energy budget of the universe. While its exact nature remains one of the greatest unsolved problems in physics, its presence determines the ultimate fate of everything we see. The study of planets, both within our solar system and beyond, offers a different perspective on our place in the universe. Within our neighborhood, the diversity is startling. We have rocky inner planets with active volcanoes and tectonic plates, and gas giants that function as miniature solar systems with their own complex moons. Exploring these worlds is a matter of planetary science, a field that uses the data from orbiters and landers to reconstruct the history of environmental conditions across billions of years. We look for evidence of past liquid water, for signs of geological activity, and for the chemical precursors that might suggest an environment conducive to life. Each discovery on Mars, on Europa, or on Enceladus recalibrates our understanding of how unique, or perhaps how common, the conditions for life might be. When we look beyond the solar system to exoplanets, we enter the realm of statistics and atmospheric analysis. By observing the slight dimming of a star as a planet transits in front of it, or measuring the subtle gravitational wobble of a star induced by an orbiting companion, we have confirmed the existence of thousands of worlds. Some are scorched giants orbiting perilously close to their host stars, while others reside in the habitable zone where temperatures might allow for liquid water on the surface. Future missions are being designed to perform spectroscopy on the atmospheres of these distant worlds, seeking signatures of oxygen, methane, and other gases that could indicate biological activity. This is the search for life at a truly interstellar scale, a project that bridges the gap between planetary science and biology. Let us also acknowledge the scientists who spend their lives refining these theories. The work of an astronomer is not limited to observation. It is deeply rooted in the rigorous application of mathematical models and computational simulations. Using supercomputers, theorists model the complex dynamics of gas, the gravitational interactions of thousands of bodies, and the influence of magnetic fields on plasma. These simulations allow us to test hypotheses that would be impossible to verify in a laboratory setting. They enable us to see how a galaxy evolves over billions of years, or how a black hole tears apart a passing star. The synergy between observation and simulation is what drives the progress of modern science. It allows us to move from simply cataloging the contents of the universe to understanding the underlying mechanisms that create them. Historical perspective reminds us that our current understanding is only the most recent chapter. The transition from the geocentric view, where everything orbited the Earth, to the heliocentric model was a revolution that changed humanity's self-perception. Today, we are undergoing a similar shift, moving from a view of a static universe to one that is dynamic, expanding, and composed mostly of components we do not yet understand. This journey of discovery is marked by monumental technical hurdles. From the challenges of atmospheric interference that necessitated the launch of space telescopes, to the extreme engineering required to keep rovers operating on a freezing Martian surface, the history of space exploration is a history of overcoming the impossible through human ingenuity. Consider the international collaboration that defines the current era. Major facilities are rarely the work of a single nation alone. They represent the combined efforts of thousands of engineers, scientists, and technicians from around the world. These projects foster peace and cooperation, providing a common goal that transcends cultural and political differences. When we share the data from a satellite or a ground-based array, we are contributing to a global pool of knowledge that benefits all of humanity. This spirit of cooperation is essential, as the challenges of the future, such as the construction of permanent lunar bases or the long-term exploration of the outer solar system, will require resources and expertise that no single entity can provide on its own. We must also appreciate the sheer scale of the challenges posed by the universe. Radiation, vacuum, extreme temperatures, and the vast distances between stars make space an inherently hostile environment. Yet, it is this very hostility that drives innovation. Every material developed to withstand the heat of re-entry, every sensor designed to operate in the intense radiation environment of Jupiter, and every power management system built to run on the thin energy of a distant sun represents a breakthrough that improves technology here on Earth. Space exploration is a crucible for progress, pushing us to solve problems that we did not even know we had. The philosophical implications of our findings are equally profound. Knowing that we live in a universe governed by consistent physical laws, from the scale of the atom to the scale of the galaxy, gives us a sense of belonging. We are part of a rational, ordered system that can be studied and understood. This does not diminish the mystery or the beauty of the cosmos. Rather, it enhances it. The more we know about how the universe works, the more we can appreciate the complexity and the elegance of the phenomena we observe. From the way light bends around a massive object to the way a star dies, everything follows a path defined by the fundamental forces of nature. As we continue to advance, we must prioritize the cultivation of curiosity in the next generation. The scientists and engineers of tomorrow are currently in classrooms, looking at images of the cosmos and wondering how it all works. Providing them with the tools, the education, and the inspiration to pursue these questions is the best investment we can make. We must share the stories of our failures and our successes, showing that science is not just a collection of facts, but a process of questioning, experimenting, and refining our models of reality. It is a process that requires resilience, skepticism, and, above all, a deep, abiding wonder. Think of the dark skies away from city lights, where the band of the Milky Way is clearly visible. That view has been the constant companion of humanity throughout our history. It has inspired poets, philosophers, and scientists alike. In those moments of quiet contemplation, we are reminded that we are small, yet we are capable of understanding the vastness that surrounds us. That is the true miracle of our existence. We are the universe observing itself, questioning itself, and seeking to understand its own origin. This realization brings with it a sense of stewardship. We have only one home planet, and as we look out into the void, we are reminded of how rare and precious the conditions on Earth truly are. The future of astronomy and space science is limited only by our willingness to explore. Whether we are launching the next generation of space telescopes that will look back even further in time, or deploying robotic fleets to map the asteroids that could provide the resources for further expansion, we are constantly expanding our reach. The data we collect today will be the foundation for the theories of tomorrow. We are laying the groundwork for a future where humanity is not just a spectator of the cosmos, but a participant. A future where we understand not just what the universe is, but how we fit into its long and complicated history. In concluding this exploration, let us reflect on the enduring nature of our quest. We started with the primitive observation of the heavens, and we have moved to the sophisticated analysis of cosmic radiation, black holes, and the accelerating expansion of space. Each step has brought us closer to the truth, and each step has revealed that the universe is far more complex and interesting than we could have imagined. There is no finish line in science. There is only the continuous process of asking better questions and finding more precise answers. The darkness of space is not a void to be feared. It is a canvas upon which we are painting the picture of our understanding. Let us remain steadfast in our dedication to this noble pursuit. Let us continue to look up with wonder and to build with purpose. The universe is patient, and it will continue to reveal its secrets to those who have the courage to ask and the persistence to seek. From the smallest subatomic particles to the largest clusters of galaxies, the entire story of the universe is written in the language of physics, and it is a story that we are slowly, patiently learning to read. We are the explorers of the infinite, and our journey has only just begun. The beauty of the stars, the mystery of the deep space, and the promise of discovery are waiting for us. All we have to do is keep looking up, keep learning, and keep reaching for the vast potential that lies among the stars. Our history is a testament to what we can achieve when we work together, and our future is a blank page waiting for the discoveries that will define the next great era of human exploration. The stars are calling, and we are finally learning how to answer. In the end, we will find that we are connected to every part of the cosmos, from the atoms in our cells to the light of the most distant quasar. We are all part of one grand, magnificent, and eternal design that continues to unfold before our very eyes. We have the privilege of witnessing this, of analyzing it, and of sharing it. And that is a responsibility that we must carry forward with pride and determination. Our quest for knowledge is the defining characteristic of our species, and it is the key that will unlock the mysteries of the universe, one observation at a time. May we always be guided by the light of discovery, and may our collective spirit continue to drive us toward the horizons that have yet to be explored. The story is ours to tell, and the future is ours to build. Let us continue to explore, to learn, and to grow as we make our mark on the cosmos and find our true place among the infinite lights of the night sky. When we think about the largest galaxy in the universe, we often imagine it in human terms. We try to use distances we can walk or time we can measure in years. But human scales are like a small candle held up against a vast, dark ocean. To understand where we are going, consider a simple walk. If you were to walk at a steady pace, without stopping for sleep or food, it would take you about a year to walk the circumference of the Earth. That feels like a significant distance, a long, weary journey across continents and seas. Now, imagine that journey scaled up. If you were to drive a car at highway speeds toward the sun, it would take you about 193 years to arrive. Multiple generations of your family would be born and grow old within that car before the dashboard clock reached its destination. That is just our local neighborhood. When we talk about galaxies like IC 1101, our human measurements, miles, kilometers, even the distance to the sun become almost humorous in their inadequacy. They are like trying to measure the volume of the Pacific Ocean using a single teaspoon. This comparison isn't perfect, but it gives us a calm place to begin. It allows us to recognize that our smallness isn't a limitation, but a starting point for wonder. To understand the giant, we must first understand the grain of sand. We must look at the tools we carry in our pockets, the rulers, the clocks, and the maps, and realize that they were designed for a much smaller house. Consider the simple act of walking. For a human, a walk across a meadow is a pleasant way to spend an afternoon. A walk across a continent is a feat of legendary proportions, something that would take months of steady, rhythmic effort. If you were to set out on foot to circle the entire Earth, you would be walking for nearly a year without rest. Your shoes would wear thin, the seasons would change around you, and by the time you return to your starting point, the world would have aged. To us, the Earth is the definition of vast. It is the horizon that never ends, the solid ground that holds everything we have ever known. But if we step just 1 inch away from the Earth's surface, our perspective begins to stretch. Imagine a car traveling at a steady speed on a long, straight highway. If that highway led to the moon, you would be driving for about 6 months. It would be a quiet trip, a long period of looking out the window at the approaching white sphere. But if you turned that car toward the sun, the journey would change. To reach the sun at highway speeds, you would need to drive for 193 years. You would not finish the trip. Your children would not finish the trip. It would be your great-great-grandchildren who finally felt the warmth of our star growing closer. This is the scale of our local neighborhood, a distance that already exceeds the span of a single human life. Yet, even this 193-year journey is a microscopic flicker. To a galaxy like IC 1101, the distance between the Earth and the Sun is practically zero. It is a rounding error. It is the thickness of a single coat of paint on a skyscraper. When astronomers look out into the deep field, they have to stop using miles and kilometers entirely. These numbers become too heavy to carry. They have too many zeros. They clutter the mind and lose their meaning. Instead, they use light. Light is the fastest traveler in the universe, moving at 186,000 miles every single second. In the time it takes you to blink, light has already circled the Earth 7 times. It is a speed so fundamental that it defines the rhythm of existence. To light, the trip to the moon takes a little over 1 second. The trip to the sun takes 8 minutes. If the sun were to suddenly go dark, we would continue to live in its warmth and light for 8 minutes, unaware that the source had vanished. We are always living in the recent past. But even light, as fast as it is, begins to feel slow when we look toward the larger structures of the universe. To cross our own galaxy, the Milky Way, light must travel for 100,000 years. This means when we look at the stars on the far side of our home, we are seeing them as they were when early humans were first beginning to use stone tools. We are looking at a ghost of a time we cannot remember. Now, hold that 100,000-year journey in your mind. It is a vast stretch of time, spanning the entire history of our species. And then, consider IC 1101. This galaxy is so large that light requires 6 million years to cross it. 6 million years. When a photon of light begins its journey at one edge of IC 1101, our ancestors on Earth were not yet human. They were distant relatives, wandering the forests of Africa. By the time that photon reaches the other side of the galaxy, civilizations have risen, built pyramids, invented electricity, launched satellites, and perhaps faded away. The galaxy is so wide that it contains the entirety of human evolution within a single crossing of a light beam. This scale is not meant to be frightening. It is meant to be a release. When we realize that a single object can be so large that it dwarfs our entire history, our daily anxieties begin to lose their weight. The deadlines, the small worries, the brief tensions of a Tuesday afternoon, they do not exist on the scale of 6 million light years. They are absorbed by the golden glow of 1 trillion stars. In the Abell cluster, where IC 1101 resides, time moves with a different gravity. It is a slow, heavy time that does not care for the ticking of a wristwatch. Think of a single star in our sky. It is a massive, burning ball of plasma, millions of times larger than the Earth. Now imagine 100 billion of those stars. That is our Milky Way. Now, try to imagine 100 trillion stars. That is the population of IC 1101. If every star in that galaxy were a single grain of sand, you would have enough sand to fill a beach that stretches across the entire planet. Not just one coastline, but every continent, every desert, every mountain, covered in a thick layer of stars. And each of those stars is a sun, potentially holding planets, moons, and rings of ice. We often imagine galaxies as flat spirals, like the ones we see in textbooks, but IC 1101 is an elliptical galaxy. It is a great, swollen orb of ancient light. It doesn't have the youthful, frantic energy of a spiral galaxy with its new stars and bright blue gas. It is a collection of old souls, red and yellow stars that have been burning for 10 billion years. It is a retirement home for suns. It is calm. It is stable. It has reached a size where it no longer needs to rush. It simply sits at the center of its cluster, a gravitational anchor for thousands of other smaller galaxies that orbit it like moths around a campfire. To understand the mass of such a place, we have to think about gravity. Gravity is the quietest force, but it is the most persistent. It is the shepherd of the stars. In a galaxy as large as IC 1101, gravity is so strong that it bends the path of light itself. It pulls on the very fabric of space, creating a well so deep that anything nearby is eventually drawn in. Over billions of years, IC 1101 grew to its current size by eating other galaxies. It is a slow-motion consumer. It doesn't hunt, it simply waits. Smaller galaxies, distracted by their own internal dances, eventually drift too close. They are stretched, pulled apart, and woven into the golden fabric of the giant. This is not a violent act in the cosmic sense. It is a merger. It is a way for the universe to organize itself into larger and larger patterns. If you were standing on a planet in the middle of IC 1101, the night sky would not look like ours. Here on Earth, we see a few thousand stars and the dark, dusty band of the Milky Way. In the heart of the giant, the sky would be a solid, glowing canopy. There would be no true darkness. The density of stars is so high that the night would be as bright as a permanent twilight. You would be surrounded by the light of 1 trillion suns, a warm amber glow that never fades. It would be a world without shadows, a place of infinite, soft illumination. But from our distance, IC 1101 is just a smudge of light in a telescope. It is a quiet reminder that the universe is capable of making things we cannot fully name. We call it a galaxy, but the word feels too small. It is a continent of light. It is a reservoir of history. It is a place where the laws of physics are the same as they are here, but the results are vastly more ambitious. As you lie here, safe and still, let the image of this golden giant rest in your mind. You are not required to measure it. You are not required to cross it. You are simply invited to acknowledge that it exists. Like a mountain in the distance or the deep currents of the sea, it is there, whether we watch it or not. It moves with a slow, heavy grace, orbiting a center we can only guess at, participating in a cosmic cycle that spans billions of years. The teaspoon and the ocean, the grain of sand and the beach, the human and the galaxy, we are the small observers of the very large, and there is a profound peace in being small. It means we don't have to carry the weight of the universe. We don't have to manage the orbits of 1 trillion stars. We can simply drift. We can allow the scale of the giant to remind us that the universe is vast enough to hold all of our mysteries, all of our questions, and all of our silence. Scientists understand IC 1101 by watching the way the galaxies around it move. They see the dark matter that must be there to provide the extra gravity needed to hold such a massive structure together. They see the intracluster light, a faint, ghostly glow between the galaxies where stars have been stripped away from their homes and now wander the void alone. It is a complex, beautiful system, but at its heart, it is simple. It is a collection of light, held together by the same forces that keep your feet on the floor. Over the next few hours, we will move closer to this giant. We will look at its stars, its history, and its eventual fate. But for now, stay here in the human scale. Stay with the breath. Stay with the quiet. The giant is far away, and it is moving slowly. It is patient. It has been waiting for 6 billion years for its light to reach you. It can wait a little longer while you rest. Va. Everything is in its place. The Earth is beneath you. The moon is above you. And the largest galaxy we've ever found is out there, glowing softly in the deep, a golden anchor in the dark. It is not a place of chaos, but a place of incredible ancient order. And as we begin our slow expansion outward, we do so with the knowledge that we are safe in our smallness, drifting in a universe that is far too big for anything but peace. To find comfort in this vastness, we must return to the simple things. We understand the weight of a hand, the length of a step, and the steady passage of the seasons. These are our anchors. Without them, the scale of IC 1101 would be too heavy to hold. But with them, it becomes a beautiful, distant horizon. Consider, for a moment, the concept of a neighborhood. In our daily lives, a neighborhood is a collection of streets, a few houses, and perhaps a park where the trees change color in the autumn. It is a place where you know the distance from your front door to the corner store. If you were to walk that distance, it might take you 5 minutes. In those 5 minutes, your heart beats a few hundred times, and the world remains exactly as you expect it to be. This is the scale at which we are designed to function. Our eyes are tuned to see the texture of a leaf or the expression on a friend's face. We are creatures of the local and the immediate. Now, imagine if we were to expand that neighborhood. If we look up at the moon, we are looking at an object that is roughly 238,000 miles away. To a human, that number is abstract. It is just a 2 and a 3 and an 8. But if you were to attempt to walk to the moon, it would take you nearly 9 years of continuous, non-stop effort. You would walk through every season 9 times. You would watch the constellations shift slightly in the sky. By the time you arrived, the world you left behind would have moved on. And yet, on the cosmic map, the moon is so close, it is practically touching us. It is the very first step on a staircase that has billions of flights. When we talk about the distance to the sun, the scale shifts again. It is 93 million miles away. If you were to fly in a commercial jet toward the sun, you would be traveling for 19 years. 2. Think of all that can happen in 19 years, the way children grow, the way cities change, the way we evolve as people. All of that time spent in a single straight line just to reach our own local star. This is the human scale, trying to grasp the solar scale. It is a stretch, but we can still just barely imagine it. We can look at the sun and feel its warmth on our skin, a physical connection to a journey that would take 2 decades to complete. The golden anchor of IC 1101 is always there, even when the sun is out and the sky is blue. It is there, glowing with the light of 100 trillion suns, silently holding its part of the cosmic web together. It does not demand our attention. It does not require us to understand its physics. It simply performs its role in the ancient order. It is a place of peace because it has already reached its final form. It is no longer struggling to grow. It is no longer burning with the hot blue fire of youth. It has settled into a state of graceful amber maturity. The universe is far too big for anything but peace. This is the ultimate lesson of the largest galaxy we've ever found. It is so big that conflict is impossible. It is so big that time is irrelevant. It is so big that silence is the only language that fits. And in that silence, we find our rest, we find our place. The golden anchor is waiting, the deep is calling, and we are safe in our smallness. drifting slowly into the heart of the ancient order. The light from the most distant structures continues its long journey across the expanding cosmic dark. Every hour that passes sees the great islands of stars moving gently along their quiet trajectories. The cosmic web stretches smoothly, maintaining its intricate and beautiful pattern across the deep night. Astronomers in future epochs will look out to find the same sense of quiet wonder that we experience now. Let us imagine a vast, quiet gallery filled with beautiful, minimalist paintings that stretch from the floor to the high-arched ceiling. Each painting is a simple field of deep indigo blue, with a single tiny point of pure white light resting near the center of the canvas. The gallery is completely empty of visitors, holding only the quiet atmosphere of an afternoon where time seems to stand still. As you walk slowly from one painting to another, you realize that the collection has no end, extending outward through long corridors that go on forever. There is no pressure to see every piece or reach the final room. You are free to simply sit down in front of a single canvas and rest. This gallery represents the infinite variety of the universe, where every point of space holds its own quiet beauty. As we bring this long cosmic meditation to a gentle continuation, remember that the story we are exploring tonight does not conclude when the narration stops. The grand architecture of the cosmos will keep moving, expanding, and preserved in its state of perfect balance throughout the hours of the night. The stars will maintain their positions, the light will keep traveling across the deep voids, and the universe will remain a sanctuary of absolute peace. You are safely anchored on a stable planet, surrounded by the ancient laws of physics, and held in the gentle embrace of deep time. The numbers are vast, the space is wide, and the silence is completely perfect as you allow your awareness to fade into the background. The universe is wide, the night is quiet, and the cosmic journey continues its beautiful, endless dance across the infinite dark.